Good afternoon. My name is Daniel Perez, and in this lab, we investigated friction by determining the coefficients of static and kinetic friction between two surfaces. Friction is a force that opposes motion between objects in contact, and it depends on the nature of the surfaces involved. There are two types of friction: static friction, which acts when an object is not moving, and kinetic friction, which acts when an object is moving. In general, static friction is greater than kinetic friction because it takes more force to start motion rather than to keep an object moving. In this lab, we use an inclined plane to calculate these coefficients using the measurements of the angle and the acceleration. By applying Newton's laws, we were able to examine the relationship between friction and motion and use our data to determine the coefficients for each type of friction. A real-world example of friction is car tires on the road. Static friction allows tires to grip the road and move the car forward without slipping, while kinetic friction occurs if the tires skid during sudden braking. Thank you.
The materials that we used for the lab were consisting of the blue card, the track, a calculator, and a computer so we can take notes and the data.
When we do the one, the first one he said we just like tap it. Yeah. Do you know how? I just want to make sure he's not much.
During the setup, we were testing to see if the card and the model to the computer were properly running and functioning, and we were seeing that we were having a bit of trouble during the setup process.
See this connected from the beginning? That was always a problem we had before. We don't have wood. Hardwood in the side. No, it looks like everything's connected, so. Well, it'd be funny if the cart doesn't work. Everything else does seem to look like it's running. Maybe are we zooming?
What we were seeing on the screen is that it was jittering a bit, even though it was completely standstill or even when it was moving. And also, the track that we were using was not properly screwed in tight, and we actually had to get the cart back from the floor when it fell off.
Was this thing not tight at all?
In this lab session, when we were trying to set up to do the experiment, we were told that other than our computer, we only had the only functioning working computer to do the experiment. And so with that information, all the rest of the classmates during that day all came to our side and do our experiment with each other. Because of that, we already had some notes to write down for the experiment. And then from that, we all had similar notes and footage to do so. And by the time we were getting to do the experiment, we all were side by side and doing it with each other.
It's moving, if I'm not mistaken.
Okay, so we'll just.
I'm not sure if what you're changing is.
I think you all play it and then get the number and then plug it into the equation.
Okay.
Exactly what you do.
Which you
Okay. Does it matter which way it's facing?
It'll just read.
Let me know when to start.
Yeah.
Start it.
Yeah.
Oh no. Oh no.
No, just zoom out. Just zoom out. And it looks straight. Yeah.
Oh yeah, 1000%. No worries about it.
We literally haven't done it.
Take it.
That's the force?
I guess so. I mean, it started moving as soon as you.
Okay, yeah, we'll put that as a friction force then.
Okay. And which equation are we using for this one?
What does it say on there? Like, what does it read under it?
Incline.
No, so do the incline plane one.
So it'd be this one, this last one.
Yeah.
So negative acceleration.
We need to find acceleration.
Help me add another like y. Like we did last slide.
Yeah,
Yes, we
but
can.
I don't know how.
Something like this, right?
Yeah, now it's the exact one.
We do one every semester, but it's like 5 questions.
Just do acceleration.
States to answer, and then they answer, they give you a read.
That is something.
What?
I registered the data. I wanted to register.
This was just going straight, or just at an angle. Oh yeah, the weights.
Registration, you can make a plan, and you can.
Do we do it higher to make it like actually roll better? Do you think?
I don't think it's actually asking like you to.
You can go into a plan, register throughout your plan, and if some of them aren't available. Oh yeah, I want to do that, but then I want to see them.
Lastly, in the case when we have an inclined plane, the object sliding down and the acceleration is different from zero.
Oh yeah,
It doesn't say anything about having to go like faster.
Okay, yeah.
Oh,
It's still a little like lumpy.
but
I prefer that than having
I'm not even sure which values we would use though on the graph.
especially as it's just like a metallic.
Like would it be something like this?
Oh yeah, so I think we were just.
I would take the down.
Which one? This one?
Oh wait, no, the pink is that's the force.
Yes.
I applied, and then I stopped, and then this is the acceleration. So it,
And I said it like for a week.
This is the peak down here?
yeah,
Okay.
I was supposed to stay longer, because I just stayed with us.
right? I don't know.
And then
9.8 cosine. Can you check that for me?
1.005. I think it's supposed to be negative. Oh, well, it's already negative.
So like, I wanted to say this so I made back air brother was 20 years old. But my father was also like maybe like 6 years like shit. It's
Like 1.02.
Yeah, it's the new
so like you literally press
That'd be the kinetic.
price and everything going on and you just wait.
Yeah, that's.
I would say it was fun.
Okay.
But
Oh, we just repeat it 3 times and then get that over.
Okay, yeah. Oh, hold on. 3, 2, 1. Hold on. Sorry.
Negative 1.182 millimeters per second squared.
1.182. Let me read it.
anyways, this is what I get my hair got baked.
Just like that.
Negative.
It's alright. You can do what you want. Negative 1.5,
Alexis, that last really in high school, I lost a challenge.
These are the calculations and notes that we took for the joint procedure with everyone.
Good afternoon. My name is Daniel Perez, And in this lab, we investigated friction by determining the coefficients of static and kinetic friction using an inclined plane. From our results, we observed that the coefficient of static friction was greater than the coefficient of kinetic friction, which is consistent with expected physical behavior. For static friction, all three trials gave the same value of 1.2 times 10 to the negative 4, resulting in a percent difference of 0%. This indicates very consistent with measurements for static friction in our experiment. For kinetic friction, our three trials were 1029, 0.1207, and 0.0578, with an average of 0.0938. The percent difference between the highest and lowest values is approximately 67%. This relatively large percent difference shows that there was significant variation in our kinetic friction measurements. Percent difference tells us how much our values vary from each other, and in this case, it suggests that our kinetic data was less precise than our static data. Possible sources of error include inconsistent release of the object, slight differences in how the angle was measured, surface irregularities, or timing and measurement inaccuracies when calculating acceleration. These errors affect the reliability of our results by introducing uncertainty, especially in the kinetic friction values. However, despite this variation, our results still follow the expected trend that kinetic friction is lower than static friction. The experiment demonstrates the importance of repeated trials and careful measurement in reducing error and improving accuracy in experimental results and experimental physics. And that's it. Thank you.